Hi everyone, so this is our first video for our AP Physics blog. I wanted to go ahead and do just a few of the dimensional analysis problems, just so that way you kind of know what I'm expecting you to do there. The unit conversions for the metric prefixes, as well as, I think just the unit conversions is what I had on there. I think those are pretty self-explanatory. I think you should be able to do those on your own. But for the dimensional analysis, let's just look at the first two. So on number one, wrote it out here. On number one, they gave us an equation. So we had velocity is equal to velocity times a time, and then plus acceleration. So I need to show that the dimensions, meaning like units, are going to come out to be the same. So what I get on this side should be the same thing as what I see on this side. In physics, we don't always have to use units. We can just show it as a dimension. So I gave you those dimensions in a table at the top of that page, and it says that velocity is just a length over time. So it's pretty easy, because if I think about velocity's units, typical units would be a meter per second. Well, meter is a measure of length, so there's my length, and then seconds is a measure of time, so there's my time. So meters per second or length over time, so same thing. So I'm just going to plug that dimension in for velocity. So I see I have a length per time, and that's going to be equal to another velocity, length over time, but I'm multiplying that velocity by time. So I have this length over time times time. And then I'm adding my dimension acceleration, length over time squared. Or I could think about that like meters per second squared. So again, if it helps, I think about it this way too. Velocity is meters per second. I had another velocity meter per second. I was multiplying this velocity by time, so there's my seconds. And then I have acceleration meter per second squared. So if I look at this, the easiest thing for me to do is take this velocity and that time, and I can cancel the times out. So then that would leave me with this. Meters per second equals a meter plus a meter per second squared. So if I go back to my dimensions, I have a length over time is equal to length plus length over time squared. At this point, it doesn't matter what I do, because I have time squared on this side and time is not squared on this side, that this is not going to make the dimensions cancel each other out. So the dimensions in this equation are not equal, and I can't make them equal according to this. So this would be as far as I would want you to show. I can't get anything else to cancel really, and this would probably be the basic thing that I would see. If I look at number two, on number two, I have a velocity is equal to two velocities added divided by 2. So again, I know velocity is length over time. That equals length over time plus length over time. But why did I not add this divided by 2? Because that 2 is just a scalar. It doesn't have a dimension that goes along with it. It didn't have a unit. So I don't have to count that, because it's not part of my dimensions. So if we think about it in terms of units instead of dimensions, meters per second is equal to a meter per second plus a meter per second, and then again we just divided that by 2, but I don't have to worry about that, so I just rewrote it. I have a meter per second equals meters per second plus meters per second. Well, if I add meters per second, I'm still going to be left with meters per second. So my units here are the same, so since they're the same, this would be a dimensionally equivalent statement here. This would be an equation that would work with dimensions well. So if you have any other questions on those, just email me or comment on the blog, and then I'll get back with you as soon as I can. We're going to start Chapter 1 PowerPoint on Monday, so if you want to print out the notes, that would be great. You can bring them to class, and I will hopefully see you guys on Monday. Have a great weekend. Bye-bye.